All right. Sorry, Aurora. Anyway, let's go to John Dalton. Now, this right here, look right here, it says, scientists of the 18th century, that's 1700s, studied nature and materials, and it became very clear, number one, most materials are mixtures of pure substances. So if I look at this rock, that's really a mixture of this and that and this and that. A lot of things are mixtures. Two, and you don't have to write this down because there's no scientists here. Pure substances are either elements or compounds. Did we learn that? Did we learn that before? Pure substances are either elements or compounds. Three, a given compound always contains the same proportion of atoms for any elements. For example, water always contains 8 grams of oxygen for every 1 gram of hydrogen. And so what they decided was, how many ways can you make water? How many combinations of H's and O's will give you water? And they said, just one. Just one. And it's 2 H's and 1 O, and that's the only way you can make water. So then they came up with a statement. What did they say? This principle became known as the law of constant composition. If I go to Russia and I make water, there's going to be 2 H's and an O. If you go to Brazil and make water, it's going to be 2 H's and an O. There's only one way to make it, and that's called the law of constant composition. Now, this guy named John Dalton, he said, I've read what other people have said. I have my own ideas and my own experiments, and I think it's about time we did this. Do you remember in 9th grade, some people coming up with what they called the cell theory? Do you remember anything like that? He said, it's about time for you to talk to us about what cells are, what life is, okay? Well, same thing here. He said, I think it's about time we came up with an atomic theory. What do you think the atomic theory would talk about? What do you think? Matt, so what do you think? If I said we're going to make up an atomic theory, it'd be a theory about what? Atoms. And so here he is. Here's John Dalton says, here are 5 statements that I think are true, and does everybody accept these? I think it's time for everybody to accept these 5 things. So here's John Dalton. Ready? Dalton's atomic theory. Now what I'm going to do is I'm going to read it to you, and I'll ask you, do you think we believe that today? He did this in the 1700s. Do we believe this today? Number 1, elements are made of tiny particles called atoms. Now I'm looking at everybody's face, and what do you think? Do we still believe that today or not? Yes. 2, is that all atoms of a given element are identical? What do you think? Ooh, I like that. That was a fast thumbs down. Why do you say thumbs down? Because you played the grid game and you know that some oxygens have more neutrons than other oxygens? What he didn't know about isotopes. He couldn't, not back then. And he also didn't know about ions. So he was correct. Every hydrogen atom does have something in common with every hydrogen atom. It only has 1 proton, right? But he didn't know that there were isotopes and ions. So we sort of still believe that today. Number 3, the atoms of a given element are different than those of another element. Sierra, what do you think? Do we still believe that today? Do we believe that hydrogen atoms are different than carbon atoms? We do, don't we? Now back then, they didn't know that. They didn't know that. Next. Atoms of one element can combine with those of another to make a compound. Do we believe that today? What do you think? Do we believe that? We do. And the last one, he says, atoms cannot be divided. When you have a chemical reaction, they just get rearranged and they form different bonds. And we believe that today. Wow, that's not bad. 1700s, and there's only one of them I would have tweaked a little bit. Okay, tonight, since I don't see you tomorrow, I want you to look at some other scientists. I think there's 4 more in the book. See if you can find those 4 more and do what we just did in class, all right? All right, I want you to work hard, okay? I want you to work hard. I don't want to make excuses for you on the next test. Say, I'm ready. I'm going to be ready. Okay, now, what I asked you, when I asked you to put it up the first time, that doesn't mean, hey, he might not be looking at me. All right? That's not right. So I'll give it back to you, but I just don't you, I don't want you working on my work in that person's class either, you got that?
I just had all the work done already, and I was just waiting for it to be done with it, so.
Okay, just tell yourself, that's not what you're doing. When you're in class, just concentrate on chemistry, right?